Hey guys, this is part 2 of our lesson on factoring polynomials, and let's take a look at this polynomial. Now, when we look at this polynomial, we're not given any factors, so we're going to use our rational root theorem to create a list of all possible rational zeros. We've got our C term, our constant term down here, which is -1, and so our C term factors are plus or minus 1. And our leading coefficient, our D term for leading, is 2. And so we've got plus or minus 1, plus or minus 2. Remember, our rational roots are C over D. So our possible roots here are plus or minus 1 and plus or minus 1/2. That's it. So we can evaluate the possible zeros to find a factor. When we plug in 1, we find out that 1 is not a factor. We can find that by synthetic division or by plugging and chugging. When we plug in -1, we have found a factor because we have a remainder of 0. We could test that either by plugging in -1 or by using synthetic division. When we use synthetic division, we get a depressed polynomial. And our depressed polynomial is actually 2x squared plus x minus 1, which we can then factor. And when we factor that, we get 2x minus 1 and x plus 1. Now, hopefully you'll notice that this x plus 1 is up here twice. So it's twice the factor of the polynomial. It is a double root of the function. We can also say that it has a multiplicity of 2. Multiplicity 2. Because it's going to be multiplied by itself twice, has a multiplicity of 2. Let's take a look at some special factoring patterns. You've already seen some of these previously, and you still need to learn them if you haven't done so already. So this first pattern was a difference of squares, and we found out that when we had a difference of squares, we could factor it as a plus b times a minus b. So as an example, x squared minus 9, we could just say was x plus 3 and x minus 3. Boom, boom, factoring done. Super easy. All right, we had a sum of squares that we could factor like this. A plus bi times a minus bi. So x squared plus 9 could be factored as x plus 3i and x minus 3i. Those are our two factors. So those should be familiar to you. I've had you mark that page and told you need to learn those. We've also seen, oh, nope, we haven't seen yet, a sum of cubes pattern. And the sum of cubes pattern looks like this. A cubed plus b cubed can be factored as a plus b, and then a squared minus ab plus b squared. And a difference of cubes is a minus b times a squared plus ab minus b squared. Right? So you do need to know and recognize these. Sorry, I think I covered up the microphone at some point. Hopefully you heard that last part of what I said, which was let's try it with some numbers. So that we're not just looking at a's and b's. So we have x cubed minus 64. We're being asked to factor that. Hopefully we can recognize right away. Since this is a cube term, let's see if this is a cube term. It is, in fact. We can rewrite that as x cubed minus 4 cubed. We should know our perfect squares and perfect cubes. You should know those, you should know those, you should know those. So 64 is a perfect cube, so we're going to rewrite that as 4 cubed. We're then going to use our difference of cubes pattern, which was a minus b times a squared plus ab plus b squared. Okay, this is our a term and this is our b term. So let's see what that looks like. We have x minus 4, and then we're going to take a squared, so x squared, plus ab 4x plus b squared. There's our b squared. Let's simplify that, and we get x minus 4 times x squared plus 4x plus 16. Let's factor 8c cubed plus 27d to the 6. Now again, if you see the c cubed, you want to be looking for perfect cubes, and we have some perfect cubes here. 8 is a perfect cube, so we can write 8c cubed as 2c cubed. Cubed root of 8 is 2. 27 is a perfect cube, so we can write 27d to the 6 as 3d squared cubed. And now we have a factoring pattern. Now we have a sum of cubes factoring pattern. Our sum of cubes factoring pattern says a minus, a plus b, so here's our a, and here's our b, a squared minus ab plus b squared. So we're going to plug all that in. I would even recommend that before you do that, you actually write a plus b, and then you substitute in using parentheses to make sure that you get everything in its proper place. We'll then simplify, and we get 2c plus 3d squared times 4c squared minus 6cd squared plus 9d to the fourth. Now, if you didn't recognize that sum of cubes or the difference of cubes in this factoring patterns, that would have been very difficult to factor. Some polynomials can be rewritten as quadratics and factored using previous methods. Factoring a common factor from several groups of terms may also reveal a common binomial factor. Let's take a look at this one. X to the fourth minus 5x squared plus 4. I'm going to rewrite that as x squared minus 5x squared to the first power plus 4. And now I have a 2 and a 1 and a constant. That looks just like a quadratic. We're going to use grouping here. Two factors of 4 that when multiplied equal 4, but when added equal negative 5. Well, that's negative 4 and negative 1. And I'll put my middle term there, and now I can factor by grouping, just like we did before. Okay, in my first group, I have x squared minus 4, and in my second group, I have x squared minus 1. Now, there are some steps skipped here. Okay, we have x squared times x squared minus 1, x squared minus 1. X squared squared is the same thing as x squared times itself, and then that's where we got our two groups. And we can write that furthermore as x squared, or x plus 2 and x minus 2. We have a difference of squares, and this is also a difference of squares, so we'll write that as x plus 1 and x minus 1. So we end up with 4 different factors. This should have been a clue on how many factors you were going to end up with. Let's factor x cubed minus 5x squared minus 9x plus 45. We're going to split it in 2 and factor by grouping. Factoring these two things, which have something in common, an x squared, and we'll factor these two things because they have a negative 9 in common. I get x squared times x minus 5 plus negative 9 times x minus 5 as well. We can rewrite that as x minus 5 and x squared minus 9. We should recognize here a difference of squares pattern, so we can go ahead and split that up to x plus 3 and x minus 3 with our original x minus 5. All right, we did a lot of things today. We found remainders. We can find remainders by plugging in, or we can find remainders through division. That was our remainder theorem. We can evaluate functions using the remainder theorem. You can actually, instead of plugging and chugging a number, you can divide using synthetic division, and whatever your remainder is, that's the value of the function. We factored polynomials using the rational root theorem, using the factor theorem, and synthetic division. The rational root theorem was all the factors of C over all the factors of D. We looked at some special rules as well. Those difference of squares and a sum of squares, difference of cubes and the sum of cubes. And we did a lot of different things to factor these polynomials. So take it all in, write questions that you have. We'll go over each of these things again in class.